These are the solutions to question number 3 from the 2015 CHAOS examination. Question 3a, we have this polar system and we want to prove that there exists a limit cycle by constructing a suitable annular region. And for part B, we want to consider this Cartesian system and prove that there exists a limit cycle using suitable level curves. And we're given a hint that we use this Lyapunov function. So for part A, we have dr dt and d theta by dt. The origin is the only critical point because theta dot is strictly positive. So the origin is the only critical point and the flow is always counterclockwise. On r equals 2, so we have to choose r values. We want to choose r values so that we get an annular region where on the outside the flow is in and on the inside the flow is out. So let's just take r equals 2. If you put r equals 2 into this formula, then if you plot dr by dt against, so you plot dr by dt for this one, then we get this function here, and you can see quite clearly that this is always strictly negative. This value here is -2, so this is always strictly negative. So dr by dt is negative, so the flow is in. So the flow is in on r equals 2. Now we look at r is equal to the square root of 0.05, so we substitute r is equal to the square root of 0.05, so in here, and we plot this function, then now you can see that this function is always strictly positive, because here's 0. This function is always positive, so dr by dt is positive on r equals 0.05 square root. So that means that we have an annular region. The origin is the only critical point, so then you think, well, where can the trajectories go when they enter this annular region? And the only place they can go is to a limit cycle. So there exists a limit cycle by the corollary to the Poincare-Bendixson theorem. Now for part B, we have this Cartesian system. We want to work out dv by dt. So dv by dt is partial dv dx dx dt plus partial dv dy dt. So this is from second year. This is the chain rule from the second year. If we substitute the values for dv dx, dv dy, dx dt is here, and dy dt is here, then we get this expression, which simplifies to dv by dt is y squared times 4 minus x squared minus 4y squared. Now, on the curve x squared plus y squared is 1, the flow is out, and that's because we are so inside this red ellipse, then x squared plus 4y squared is less than 4. So inside here, x squared plus 4y squared is less than 4. So we know that, and here, x squared plus y squared is 1. dv by dt will be positive. So the flow is out there. Outside this ellipse, we know that x squared plus 4y squared is bigger than 4 outside the ellipse, which means that on the curve x squared plus y squared is 4, dv by dt will now be negative. So the flow is negative in here and it's positive on there. Okay, and it turns out that the flow is actually on the ellipse 4 minus x squared minus 4y squared. So that is your limit cycle. So we can take any circles inside here and the flow will be out, and we can take any circles on the outside and the flow will be in. So this is your limit cycle. And that concludes the solutions to question number 3.